In traditional software, there is a rule, and that rule can be simple. For example, if vibration exceeds this threshold, then raise an alert. Or the rule can be extraordinarily complex, the product of decades of research in mathematics, in thermodynamics, in signal processing, accumulated understanding of how physical systems actually behave under stress. The rule can fill pages and pages. It can encode the lifetime work of engineers and physicists. But whatever its complexity is, the rule is still inspectable. In traditional software, someone actually wrote it. You can open it, you can follow it, you can question it, you can trace exactly what it does and why. It has an author. It has a logic you can walk through step by step. That structure of traditional software is always the same. Input plus rule equals output. You have a situation, you apply a rule, you get a result. The rule is the fixed center, the thing that was designed, validated, and owned. Machine learning inverts this completely. You have inputs, for example, sensor readings, historical measurements, operational data, images. You have outputs also, for example, this was a failure that we documented, this was not a failure. So you have on your documentation or in your data, in your historical databases, you have inputs and you have outputs, but you do not have the rule. So instead of finding it yourself through research, through physics, through mathematics, you ask the machine learning system to infer it from the relationship between these historical inputs and these historical outputs that you already have. So in this case, input plus output equals rule. So the rule is no more the starting point of the center or the center. It emerged at the end. And what emerges is a mathematical structure. We still call it a rule, but it is not the same kind of rule that we know in a traditional software. It is a mathematical structure with weights, numbers, a compressed pattern extracted from your data. So it behaves like a rule. It generalizes, it predicts, but you cannot open it the way you open traditional software and read what it says. This is not because it is hidden, but because it was never written. It emerged. So the learned rule is not a law of physics. It is not something derived from first principles or found in a technical manual. It is the pattern that best fits the history of your data, the failures you recorded, the operations you logged, the past this specific machine or this specific system lived through. Now here where this mechanism creates something most organizations never name. In traditional software, if something goes wrong, you find the rule that caused it, you read it, you fix it, you know who wrote it. However, when a machine learning system fails in a way nobody anticipated, the rule that produced that failure was never written by anyone. It emerged from data. And the question of who is responsible for what it infers is not answered anywhere in the code base. It has to be answered by the organization. Most never do, until something actually goes wrong. In the next episode, we go one level deeper from features humans design to representations the machine builds by itself from raw data.